Okay, so going to be looking at sums and differences of angle. You need notes out, so look at your notes. Yep, so you can look at the diagram. I'm not going to reproduce that on the board. Alright, so on page 87 of your notes. So we're going to develop formulas for finding trigonometric functions of sums and differences of angles. Okay, so in other words, we will develop formula for cos of x plus or minus y, sine of x plus or minus y, and tan x minus y. So basically we're given two angles, we can add or subtract them, and we're going to have a simplified expression for those angles. So consider the diagram below. Okay, so we've got the unit circle, okay, radius 1, which is what it means with the unit circle, and then in the sort of the top half of the circle, the top semicircle, we have put in a triangle, okay. Yeah, I should realise I have to draw it now. Okay. The circle, we've got an interval AB, okay, that subtends the angle at the centre of the circle. Right, so which has angle x take away y inside that triangle there. So basically what this means is the angle from the x-axis to the point A is value y. Okay, and then the overall angle over to from the x-axis to the point B is the variable angle x. So therefore inside the triangle is the whole angle x, take away the outer angle to get the value of the angle inside there. The value of x take away y. Okay, so going back to your when we looked at the ratios where sine, cos and tan were positive in which quadrant. Okay, so point A has coordinate in respect to cos and sine, cos y and sine y. Okay, because when we take the right angle there, okay, so the interval AO and BO is 1 because the radius of the circle. Okay, and then remember the displacement for this way was x and this way was y. So going back to our mathematics lesson. And basically we took cos of y, so cos of the angle y, which is the adjacent length x over the hypotenuse 1. That means the x value has the x has value cos y. So y is the angle inside the triangle. And then sine of the angle at y is equal to the opposite, which is that y over there, over the hypotenuse. So the y value is going to be sine y. Okay, and that's why the coordinate for A is cos y sine y. Okay, doing a very similar setup, okay, to over this side. Okay, we're going to get that angle over there as cos of x and sine of x for that coordinate at B. Okay, so that was covered in more detail in the mathematics lesson we had. Right, so we wanted to consider the distance. Alright, so if D is the square root of x2 take away x1 all squared plus y2 take away 1 all squared. Okay, so if we take the square of both sides, we'll eliminate that square root, like we did with the lockers yesterday. So it'll be x2 take away x1 all squared, plus y2 take away y1 all squared. So we just removed that third. Okay, so now we need to calculate the distance AB. Okay, so we're given the coordinates of A, which is cos y sine y, and for B as well. So let's call this x2, y2, x1, y1 for those respective values. So the distance AB, so we're substituting for the distance here, so that will be the length of the interval AB squared. Okay, so for x2, x1, y2, y1, I'm going to substitute those variables in there. So it'll equal cos x take away cos of y all squared, plus sine of x take away sine of y all squared. So we are developing formulas for if we have two angles and we're doing a sum or difference of those two angles, okay, and developing formulas to sine sine of x plus or minus y, cos of x plus or minus y, and tan of x plus or minus y. Okay, so first we're going to do a but we're going to go through a proof. So I'll show you how it works. Alright, so let's expand this. So you got the perfect square. So you got cos squared x, take away 2 cos x cos y, plus cos squared y when you expand the first bracket. And then expand that second bracket. So you got sine squared x, take away 2 sine x sine y plus sine squared y. Okay, so we set the variables for the coordinate A was cos y, sine y, okay, and there's the set out, and this is when we did our which angles were positive in which quadrant, okay, so it's back to our mathematics work, okay, so the x value has cos y, and the y value has sine y for that side. Similar setup, we're going to get cos x, sine x. Okay, and now we're finding the distance of the interval AB, so we set the distance formula. Okay, so that you have covered last year. And then to remove the square root, like we did with Locus, we squared both sides of the interval to remove the square root. Okay, so we're now finding the distance of the interval AB. Okay, using our x2, y2 and x1, y1. Alright, let's tidy it up. So, AB squared is going to be sine squared x plus cos squared x. Okay, because we know the result of sine squared plus cos squared are the same angle. Right, so I'm just rearranging this just to tidy it up a bit so I can put some substitutions in straight away. I'll also have sine squared y plus cos squared y. Okay, so we can put a very simple expression for both of those in there. And then what's left, I've got a negative 2 cos x cos y, take away 2 sin x sin y. So let's take the negative 2 out. And then it'll be a plus sign in the middle. welcome everybody. Right, so Michaela, we are now developing formulas for sine, cos and tan of x plus or minus y. So we're adding or subtracting, it'll take the difference of two angles and coming up with an expression for all those six actually, expression. So we do that by finding the length of the interval AB, by setting the coordinates of A and B, which is relation to your right angled triangle when we did the positive angles in the quadrant in mathematics lesson. And we substitute into the distance formula. Right, so AB all squared, so it'll be 1 plus 1, so sine squared x plus cos squared x is 1, sine squared y plus cos squared y is also 1, remembering they have to be the same variable, or same angle. Okay, you can't have sine squared 30 plus cos squared 45, that doesn't equal 1 because you've got two different angles there. Okay, it has to be the same angle. Alright, so in regard to the right hand side, we can't do too much more with that right now. So take away 2 cos x cos y plus sine x sine y. So it'll be 2, take away 2 cos x cos y plus sine x sine y. Okay, so that's using the distance formula, and that's as far as we know how to simplify it at the moment. Okay. Right, so I don't think you're specifically required to know the proof, and you'll end up with applying the results. However, like I've been saying, if I show you these proofs, things will start clicking a lot easier overall in the topic. Okay, you see how things work. There's a lot of formulas based on this topic, so if you have the opportunity to derive some, alright, it would help you with your understanding overall. Alright, so I use the distance formula to calculate the length of the interval AB. What's the other way that you have now learnt that I can calculate the length of that interval? Sine rule, what else? Cosine rule. Okay, so we need to now decide which one I'm going to use. So I have two sides and the included angle. Okay, I don't know these two angles up here, so I don't know two angles on two opposite sides, but I do know two sides and the included angle. Alright, so let's do the same setup with the distance AB using your cosine rule. Right, so that's equation 1. Right, c squared, so that's the little c up here, or technically it's AB. So AB, so we're finding the length of that interval. Substitute it into this formula again. Into the cosine formula. Right, which should be A squared plus B squared, take away 2AB cos of the angle at the origin. Okay, in relation to my diagram. Right, so A is 1, B is 1, so we're going to have 1 plus 1, and then A times B is also 1, so we're going to have 2, take away 2 cos of the angle x take away y inside that triangle. So 1 plus 1, take away 2 cos of the angle x take away y. Okay, so if this first angle to the interval A and the x-axis has value y, and from the x-axis to the interval B, the whole angle has size x, Therefore, the angle inside the triangle is going to have x take away y. That's why we've got the x take away y for the value of that angle. This is what I've set. Okay, so that's just tidied up. So we've got 2 take away 2 cos of x take away y. And now equation 2. So we have 2 expressions for AB squared. Okay, so we've got number 1 and number 2. So now I'm going to substitute equation 1 into equation 2. Alright, so 2 take away 2 cos of x take away y. So I'm writing this side first. So we probably should say 2 into 1. Oh no, that's correct, 1 into 2, yeah. Alright, which equals 2 take away 2 cos x cos y plus sin x sin y. Okay, so this is now algebra. Alright, so you have positive 2 that you've got addition to both sides. Because you get the same thing on both sides, you can cancel that. You now are multiplying both sides by minus 2. Because what you've got left is minus 2 cos of x take away y, which equals minus 2 of that whole expression on the right. Because you're multiplying by the same number, you can cancel those 2 out. And you're left with an expression for the difference of 2 angles and take the cos of that. So cos of x take away y is equal to cos of x cos of y plus sin of x sin of y. Okay, so that's the first one. There's 5 more. We don't have to do that same proof 5 times.
Can I get a tissue, please?
Yep.
Is it on there?
Mr. Murray just got in, so he's
Oh,
got
this-
all in the classroom. Okay, that's the first one. Alright, that's your set. And I'll call it number 3. Alright, so now let's set y equals negative y into equation 3. Okay, so every time there's a y, I'm going to make it a negative y. So, cos of x take away a negative y. Okay, so I'm replacing the y with a negative y, because I've still got the minus sign there. So this is equal to cos x, cos of negative y, plus sine of x, sine of, in brackets, negative y. Okay, so all my y's are replaced by negative y. So, left hand side, then minus minus becomes a plus. So now we're going to have an expression for cos of x plus y. Okay, so considering your number plane, the angle of cos of negative y, so if you go down to the value of y, anti-clockwise, it's going to be the same as going y in this side because all angles are positive in that first quadrant and cos is also positive in the fourth quadrant. So cos of the angle of cos of negative y will be the same as cos of y. Okay? So cos of x times cos of y. Okay, so again, if I take the angle y this way, it's going to be exactly the same as the angle y this way because they are both positive in those 2 quadrants. Right. Plus sine of x. Now, if I take a sine of minus y, so I'll go below in the anti-clockwise direction around here, okay, into where cos is only positive, okay, that means sine is negative in this quadrant. So if I take that basic angle work that I've done, okay, which is going to be a negative sine of y in that first quadrant. Okay, so sine of minus y will equal negative sine of y in the first quadrant. Okay, and that's going back to the quadrants work in mathematics. So it equals cos x, cos y, take away. So we've got the minus sign, so we're taking out the front, sine x, sine y. Then we have now an expression for cos of the addition of two angles. Okay, question. Alright, so now equation 4. Alright, so now we want to substitute now x is equal to 90 take away x into equation 3. So every time there's an x in this equation here, so our first result, I'm going to replace it with a 90 take away x. Right, so cos of 90 take away x, take away y, is equal to cos of 90 take away x times cos of y. Every time there's an x, I'll replace it with 90 take away x. And plus sine 90 take away x times sine y. Okay, watching what happens here. Cos of 90 take away x plus y. Okay, so I have factorised the negative out of the x and y there, and then that makes the sign between them a plus. And going back to your complementary angles work, we had that result as well. The sine of x, which equals to cos of 90 take away x, and cos of x is equal to sine of 90 take away x, using a complementary angles result that we had done earlier this topic, mathematics. So, cos of 90 take away x, which is sine of x, times the cos of y. And sine of 90 take away x, the complementary result is cos of x. And at the front, I've got 90 take away in bracket x plus y, so the same expression as this, okay, which would then become the sine of x plus y. Now we have the result, the sine of the addition of two angles. So asterisk number 4, asterisk number 5, there are your results. This is what you need to know. Okay? If you're following somewhat of the proof, you're doing well. Okay, if you really are unsure, you ideally are able to understand the result and use the result. Okay? Alright, so that's our third equation that we need to get. Now let's put y equals negative y into equation 5. So now we're going to get difference, the result of sine of the difference of two angles. The sine of x take away y. So sine of x take away a negative y. So now every time there's a y, I'm going to replace it with a negative y. Sine x cos of negative y plus cos of x sine of negative y. So every time there's a y, I replace it with negative y. Okay, and then exactly the same setup over here. Okay, so cos of negative y, you go backwards y degrees, exactly the same as going forward y degrees because cos is positive in both those two quadrants. Okay, if you take sine of negative y, sine is not positive in the fourth quadrant, so the resulting factor is if you go the same angle in the positive direction, it'll then become a negative sine. Okay, and that goes back to our quadrant work that we did in mathematics. So x plus, and then minus y. So then we have sine of x take away y, which equals sine x cos y. Now because sine of negative y is negative sine of y, so I'm putting the negative right out the front. Cos x sine y. Now I have the result for the sine of the difference of two angles. Question? Okay, at the end of the day, you need to be able to remember the 6 attributes I'm about to write. Okay, I'm just showing you how they work because there'll be further questions later on. And that's what I'll show you now.
So the asterisk ones we need to know.
So,
The asterisk ones we need to know.
yes. Okay, so I'm going through the setup, going through the algebra of how it works, but at the end of the day, what you need to know is the asterisk. You need to show 6 formulas for it. Alright, 10 of x plus y. Remember your 5 trig identities? What was tan equal to? Tan of theta equals?
Sine of theta over cos of theta.
Good. Alright, so therefore tan of x plus y is equal to sine of x plus y over cos x plus y. Then we're going to place sine and cos of x plus y with the expression that we have derived. So cos of x plus y is this.
Oh.
And sine of x plus y is that.
This is good.
Alright, so sine. So when you have a sine and you're expanding, so we sine x cos y with the same sign between them, so the plus sign, and then cos x sine y. Okay, so sine first angle, cos second angle, plus cos first angle, sine second angle. Alright, cos of x plus y, so you have cos x, cos y. The cos comes first, then sine, and then the opposite sign, what's inside the bracket. Okay, so you've got an addition inside the bracket, the expansion is a subtraction. Okay, take away sine x, sine y. Okay, now what I'm going to do is divide everything on top by cos of x plus y. X plus y. Hang on. Nope. Cos x cos y. So everything on the top is going to be divided by cos x cos y, and same on the bottom, cos x cos y. So, what does it look like? Sin x cos y over cos x cos y. So each term is getting divided by cos x cos y. So I've got sin x cos y over cos x cos y plus cos x sin y over cos x cos y. Okay, all over that main fraction bar of now this section, so cos x cos y, over what I'm dividing by, cos x cos y, and you'll be able to simplify that. Okay, and then now over this section, take away sin x sin y over cos x cos y. So everything getting divided by sin cos x cos y. Okay, just setting it up. Now the reason I've done that is because I want to simplify my sine over cos of the same letters to tan of that same letter. Okay, so I have cos y and cos y. I can cancel those. So I'm left with sine of x over cos of x. So what's sine of x over cos of x?
10.
So tan of x. Okay, over here I've got cos of x, cos of x. I'll cancel the same expression. And now I'm left with sine of y over cos of y, which equals
Tan
of y. On top, all over, so cos of x, cos of x over cos of x, same expression, we cancel. And we also have cos of y over cos of y. So we can cancel that. So what does that fraction simplify down to? 1. Take away. Right, so what is sine of x? So we've got sine of x, sine of y, cos of x, cos of y. What does that simplify down to?
Tan x tan y.
Sorry?
Tan x tan y.
Excellent. 1 take away tan of x, tan of y. Okay, so sine of x over cos of x equals tan of x, and sine of y over cos of y is tan of y. Okay, and that's number 7. That's an asterisk one. So tan of the sum of two angles is equal to that.
Who figured this out?
Hey,
Who figured this out?
somebody a long time ago.
That's crazy though.
Hey,
It's crazy.
but can you see it working?
Yeah.
Kinda.
Why do we use
Kinda.
sine? Why do we use like all letter?
No, and just what I was saying was crazy is the fact that someone found this.
Yep. Mhm.
Why don't we use it like a symbol?
What a nerd.
Why don't we use a symbol instead of sine? Of the pen?
Somebody who's not using up time on skateboards, Scott.
Well, they wouldn't have had them back then.
No, doubt that.
Okay, so I won't go to the last one. Okay, but tan of x take away y. So you do the same setup. Sine of x take away y over cos of x take away y. Expand it out, divide by the same thing, and then you're going to get a very similar expression.
Did we end up with more than 10 equations?
So similarly, so tan of x take away y is going to be tan of x take away tan of y over 1 plus tan of x tan y. Okay? To derive it, you put sine of x take away y over cos x take away y, expand them with your result. divide everything by cos of x, cos of y, and then you'll eventually get to that. Okay? And that's number 8. So, 3 through 8 you need to know. And now summarising your notes.
Back of my.
So on top of page 88, there are your 6 results you need to know.
Do you know what I should do? No, I might actually put maths equations on the bottom of one of the boards.
Bottom of what?
One of my boards.
I'm gonna put it on the back.
Okay, your understanding of the whole course is dependent on your understanding of these things, how they work. Okay,
Also,
that is why I'm going through them.
Something great happened last night. Ruben and I were skating, and he was doing trying to get a clip.
Okay, let's write a summary. Cause I will do
He's like, as soon as we
according
take
to your
it,
notes.
we'll go.
So x take away y.
Yeah, then this is done.
So this is what you need to know. Huh? This is what you need to know. When you have a cos of the different or the sum of 2 angles. Amanda?
Amanda.
Okay, so we have, to expand it, you have cos of the first angle, cos of the second angle, okay, and then the opposite sign of inside that bracket. Okay, so the minus inside the bracket, that means there's a plus. Sine x, sine y. Okay, so cos of the addition of those 2 angles. Alright, so again, cos x, cos y. So when you have a cos and you're expanding, the 2 cos will come first, and then the 2 sines. Alright, opposite sign in the middle. So you've got addition, means on the expansion there's a subtraction. Sine x, sine y. Okay, these are your results. This is what you need to know. Alright, sine x take away y. So I'm just going through your notes. Oh, got it past there, doesn't really matter. Okay, to expand a sine, go sine cos, then cos sine of your 2 angles. Okay, sine x cos y, the same sign. Okay. So this one will be a takeaway. When you have a cos, they are opposite signs. Alright, cos x, sine y. Okay, so sine x, cos y, sine y. Alright, sine x plus y. So we've got 2 angles and we add them together, we can simplify them with this expression here. So sine x cos y, and then the same sign in the middle, sine's the same sign. Okay, cos of x sine y. So you need to flip the order because x, y are in order according to what's in the bracket. Okay? Tan x take away y. So tan is the same sign on top of your fraction. So tan of x take away tan of y. All over 1 and then the opposite sign on the bottom. And then you multiply the tan of both angles. So 1 plus tan x tan y. Same sign on top, the opposite sign on the bottom. So tan of x plus y, so tan of x, same sign, tan of y, all over 1 and opposite sign on the bottom. So you've got a plus in the bracket, you now have a minus sign on the bottom of the fraction. The product of tan x, tan y. That is what you need to know.
Yeah, all of all that other stuff.
That shouldn't be that hard. That's pretty easy.
There are lots more coming. Right? Well, not a lot, but there's a fair few more coming. Okay, so a suggestion is to have a formula sheet, a separate page. Okay, and as you're going through each of your topics, you are listing down all your formulas. So now that you're going through extension trig, you're going to list down these first 6 formulas here. Alright, when you get to the next lesson, you've got another 3, 4, 5 formulas to write down. And then following that, you're going to have another 4. Okay?
I was talking to Mr. Sullivan yesterday about all this stuff, and he said there's like an A4 plastic thing that has signed graphs, like all the graphs on it to trace. He said it was like a green.
Math?
Yes.
Yep.
Are we able to have some of those?
I've done have it on your ones I've already given you.
They don't have the graphs. It has the circle. It has all the shapes.
Well, we'll get to that when we get to that, eh?
Cool. Thanks. This is the last. It's
Yeah.
the last cup.
Now use your fridge,
I'm using my fridge.
please.
Oh yes, please.
It's not really my fridge, is it?
Don't use the stars. Don't. Put it in there and hope it goes in.
fine.
Go away, you're having it.
What is it?
Seagull.
There's potato in. There was potato in this. I didn't even realise.
Robin, it's been 365 days.
Alright, nice and quick. Nice and quick. Want to do some examples so you see the application of these formulas working. Right. So, any questions about any of those formulas? So, part of your homework is to have a separate A4 sheet or type it on the computer or whatever. Okay? Start listing down all your formulas. Alright? There's about a dozen of them in total for this topic. Just extension trig that. Right? Remember, you've got your mathematics, you've got all your right angle triangles, you've got your non-right angle triangles as well, you've got your identities, you've got your table of exact value, and you've got your area rule. Okay, so lots of formulas. So I suggest you would spend some time creating a formula sheet per topic. Okay, right, examples. Are there any questions on anything I've done this morning?
No.
Okay,
It will be later.
and remembering the benefit of these lessons being recorded is you can go back over it and watch them again and again, and hopefully it'll make better sense for you each time you watch it. Alright? A. Simplify. Sine 2 alpha cos beta, take away cos 2 alpha sine beta. So you have sine cos, take away cos sine. Which one is it? 1, 2, 3, 4, 5.
3. Oh, 3, yeah.
Oh, I'm just
Was it the
going.
first one I looked at and I was like, is that?
It's like
It is!
I'm going.
Okay,
to-
so sine 2 alpha cos beta, take away cos 2 alpha sine beta is going to be sine of 2 alpha, take away beta. Okay? So equals sine of 2 alpha, take away beta. Okay? So that would be a simplified expression of what you got there. Okay? B, expand. Cos 2x plus 3y. 2x plus 3y.
Cos y. Whereas sine, it's sine.
Number 2, okay? Cos, remember, cos on the left, the cos 2x cos 3y, and then the opposite sign. Okay, cos is opposite. Take away sine, take away sine 2x, sine 3y. Okay, so that's just simplifying and expanding.
That's
And now we're going to have a look at an application of actually adding two angles. Find the exact value of sine 35 degrees. So this is the application. So you have done work on exact values in mathematics. So which of my exact values, angle size, can I add or subtract, and I'll get 75.
30 and 45.
Okay, so we set up as a sine 30 plus
Actually.
45. So exact value angle size of 30, 45 and 60. Of course you can also have 0 and 90. Okay, so sine 0 is 0, cos 0 is 1, tan 0 is 0. Okay, sine 90 is 1, cos 90 is 0, and sine tan 90 is infinite.
What?
Yeah. Okay, expand. So sine with a plus. So sine 30, cos 45, so sine cos. So when you have the expanding of sine, you have a sine cos, and then a cos sine of the angles in order with the same sign.
Okay.
Okay.
Miss something?
No, that was.
I get it now. It's okay.
Yeah?
Yeah.
So you're just expanding this rule here. Alright, one each. Michael, sine 30.
1 over root 2.
1 over 2.
1
1
over,
over 2.
Mina, cos 45.
1 over root 2. There we go.
Robin, cos 30.
1 over. Cos 30. From root 3 over 2.
Good. And Kyle,
Is
sine
it
45.
1 over root 2? So can I? Okay. How come
Yes.
the cos ones, the
Yeah.
sine, like, see how it's cos of x minus y? How come it's a positive in the middle, and when it's, I'll show you.
Yeah, I understand what you're
Yeah,
saying, and that's why I've done the proof.
But everything else matches. Like, everything else is the
Because I
same.
just proved it, Kyle. It
Yeah,
just
yeah.
works that way.
Don't question it.
Watch the video again. Okay, 1 times 1,
7.
2 times root 2, plus 3 times 1, and 2 times root 2. Alright, same denominator. Thank you. Alright, get your calculators out. Put sine 75 equals, write an approximation, and then put 1 plus root 3 all over 2 root 2 equals, do the approximation, they should be exactly the same.
Yes, they are.
Mathematics works.
Crazy.
That's.
Stop crying.
Alright, last one. D. Amanda McCullough, did they work? Yes? Yes? Okay, I'm just making stuff up.
Yes.
I'm
It
glad,
works.
because you would have to have a pretty cool mind to make that up.
So you don't have a cool mind, I'm sorry.
Okay, so you could also do it for sine 15. Cos 75, 15, 75 is all your exact value.
Right.
Okay, you could do it all for those as well. Yep.
Do you want us to rewrite the formula each time we do it with textbook work?
Definitely.
It's 8:30.
What kind of-
We didn't do it there.
Oh, we're doing another exam.
How are you going to learn them without doing that, Colin?
When will the assessment task be for this?
Week 2.
Week 2.
Yep.
Oh,
Sweet.
that's.
That's enough time for you to
That's enough time to procrastinate at all.
And then study.
So, we'll finish this at the end of this term, whether that'll finish with me or another teacher, and then you'll also do the extension of chapter 3 equation, which will only take 1-2 lessons. Okay, and all that will be accessible.
I've done that.
You've done circuit geometry second, so it'll be permutation, combinations, and extension tree, and extension equation.
From 3 weeks ahead. We did that.
Alright, last one. We need to show our proof. 10 on pi on 4
40 damn questions, bro.
plus x. Focusing, focus.
Pi, bro.
No.
I like pie.
sine, cos
I like the edible one because I can just
Cos
eat
of
it
X.
and the problem is solved.
plus sine of x over cos of x.
IRL, I can just
Take away sine of x.
Wait, is that
Proof.
prover? Okay.
I have so many.
Okay, so when you have a proof involving an equal sign, you need to start at one side, left hand side or right hand side, and then show that equals the other side.
Could we do left? Let's just, I don't know.
Right, so I'm going to go to the left hand side first. Okay, so again, if you're not sure where to start, start on the left hand side.
I hate the word prove.
Well, you have to get good at them. Okay, so what's the expansion for the sum two angles? For 10.
Plus like 10x plus 10y. And pi.
Tenpai. Sounds like I'm in Japanese. Tenpai.
Alright, so I've expanded my tan of pi over 4 plus x. Using my expansion result of number 6.
Like 10.
And what is tan of pi over 4? Ah, sorry.
What? Oh.
Nah.
So it's like root 3.
I think, come on guys, you should be able to tell me straight away.
Root 3.
So when we get to radian measure in your HC course for measuring angle, 45 degrees is the same as pi on 4, okay? We'll get to that when we get to that.
I'm not ready.
Alright, what's tan of 45?
Root 3. No,
One's 1.
Oh yeah. I lost that one.
I was complicated, so
Yeah, it's my fault. It's your responsibility.
Alright, you agree?
Yes.
Yes.
And my apologies.
And then that's. No, I don't know that.
Okay, so what else am I going to do?
I don't know.
Okay, so if you get to a point where you're not sure where to go,
go right hand side.
if you're not sure where else to go to the other side. So we need to get the right hand side simplified down to expressions involving ones and tens with the opposite sign. So we have the opposite signs already. We have causes and we have sines. So we're almost there. What can I do? What have I done already today that made things into 10? How did I derive these two? Well, how did I derive that one? What did I divide everything by?
Oh. Oh, it sounds
Sine,
Right.
cos, and cos.
Cause.
So divide everything by cos of x. Okay, because I want cos of x divided by cos of x will give me y1. Sine of x divided by cos of x which should give me y10. So, cos of x over cos of x plus sine of x over cos of x all over cos of x over cos of x. Take away sine of x over cos of x. Dividing everything by cos of x. Alright, so the cos x cancelled. 1, and then what is sine of x over cos of x?
10.
Identity number 3.
Oh, look at that.
Okay, which is now what I've got up to on my left hand side. Okay, equals LHF. So I don't have to keep going with this one until I get to the left hand side of this, tan of 45 plus x. I don't need to do that, okay? All I need to do is get up to where I've got up to in one of the sides, or what I've already written down for one of the sides. Okay? Prove that. Yep, we're done.
Oh.
Yes.
When you put that, you put mine into it.
Alright. So, as 3 of you have noticed as you were coming in the room that I've already started the lesson. Okay, so we really need to get them started about 7:35 at the latest, so we can get through the work. And you have a bit of a break before roll call, myself included. Especially my 7-period day I've got today. Okay, so please make every effort to be here on time.
I don't have to do IT, and I don't have to do English.
Why?